So we talked about some of the dangers that to look out for. Now I'm going to talk about or worse. There's the idea of things that are as extreme, as surprising, or worse. And this is for two things. It's for doing statistical tests and the idea of what would be more surprising or extreme in a test. And the other is connected to this whole idea of post-hoc hypothesis, things to watch out for if you have to make hypotheses after the event, if you have to look at your data, work out what you think is true and then do stats, how to try and make some estimate as to how you should correct for that. So first of all, what to test for. Imagine I'm tossing my coin, I toss it and I get this pattern. I get a tail, a tail, head, 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 tail, tail, head, head. And then I think to myself, well, is that a fair coin? Does that give me any greater or less belief that the coin is a fair one? So you can sort of think about that pattern. Imagine if I tossed 10 heads in a row. Does that feel the same or different? Is it more or less? I imagine these a similar pattern with 100 in each, 100 heads in a row or 100 mixed up like a bun. Okay, now the probability of getting the pattern at the top, getting first of all a tail, then a head, then a tail, then head, 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 tail, tail, head, head, is exactly 1 in 2 to the 10, which is 1 in 1,024, so about 0.001. It's about 1 in 1,000. You know, of getting just that exactly that pattern. The probability of getting 10 heads in a row is also exactly 1 in 1,024. Yeah, so the chance of getting exactly that pattern, the one at the top, is 1 in 1,024. The probability of getting exactly the pattern at the bottom, all heads, 1,024. Doesn't look very different. Both of them are quite unlikely things to happen given a fair coin. So, but gut-wise, you sort of know that's not true. You know, surely the heads, all those heads, is a more extreme thing to happen. And it's to do with this sort of, the idea of things being the same or worse. When you got all heads, the only thing that would have been equally surprising, given a fair coin, would have been all tails. So there's only two things that are the same or worse or more surprising than getting all heads, and the other one is all tails, and they're both the same. However, with the pattern we had below, the tail, head, etc., there were 6 heads and 4 tails, and you sort of know actually it doesn't, you know, they could have come in any order, but the only things that are, the things that are more surprising, or at least as surprising as having 6 heads and 4 tails, is 7 heads, 8 heads, 9 heads, 10 heads, and similarly with the tails. So in fact, pretty much the only thing that's less surprising, giving an even coin, is if it's 5 of each. So nearly everything in the second case is equally or more surprising, whereas in the first case there's very few things. And it's this idea that things are worse or more surprising that makes something surprising. If you can think of lots and lots of things that will be equally as interesting, then that probably means the thing isn't interesting. If there are few things that are as interesting as it, then it becomes unique in a way. It's a bit like every person is unique, but lots of people, shall we say, are unique in more similar ways. And then there's perhaps, I think today is something like the anniversary of the death of Elvis Presley. So, you know, we're all unique. I'm a unique individual, you're a unique individual, but maybe Elvis Presley a little bit more unique. Similar way here. Now, for numeric data, to work out that worse or better, or you know, same or worse, is relatively easy. You just basically look at the number. So something like 6 heads out of 10 tosses, what could be the same or worse than that? Well, 7, 8, 9, 10. And this is this one-tailed, two-tailed stuff, but, you know, if you're equally surprised whether it's more heady or more taily as a non-fair coin, then there's also 6 tails, 7 tails, 8 tails, 9 tails. So basically, how likely is it to get that pattern or something at least as surprising? Well, basically the only thing that's not less surprising is them being equal. The probability of getting exactly 5 heads and 5 tails, if I've done my sums right, is 252 over 1,024, which is about a quarter-ish. So the likelihood of getting that pattern, or one that's equally surprising, is about 75%, about 3/4. You can do the sums for other things as well. If I had 9 heads out of 10 tosses, then what's the same or worse? It's 9 heads, 9 tails, all heads, all tails. And that works out about 22, well, exactly 22, I was out of 1,024 of getting that. That's about 2%. So that's more surprising of getting that or worse. And just to do one other, if it was 90 heads and 100 tosses, which sounds the same as 9 and 10, but actually, remembering when you get lots and lots, you expect things to average out. And in fact, if you do the sums for that, I won't do them, but you know, what's more surprising? Well, as surprising or more surprising, 90 heads, 91 heads, 92 heads, up to 100 heads, and similar for the tails. And it works out less than 1 in a million, the chance of seeing that. So when you get, if you've got 90 heads in a row, I would start to think something was going on weird out of my 100 tosses. However, sometimes these things can be a lot less obvious. So I'll go from coin tossing to cards, right? And these are my patience cards. I use these to play sort of games of solitaire card games where I'm just want to waste a bit of time, or I'm a bit, you know, a bit tired, and I just have a little gap. And there's one I play where they all go out in this big square like this. And one day I was doing it, and I'd got part way through, and I'd been sort of placing the cards out one by one. And then as I put them out, I got the, whoops, I've got it the wrong way around. I got the Jack of Clubs, followed by the 10 of Clubs, followed by the 9 of Clubs in a line there. And you can see them there. And I thought, whoa, that's weird. Have I, is this to do with the fact that I haven't perhaps shuffled my cards well? You know, perhaps when I was playing before, that what I'd done had involved them being all piled up on each other, which often happens. In fact, then I realised the game I'd played before wouldn't have done that. But it seemed like really, really odd. So if you think back to the sort of the plains and gnarly, you know, is this an omen? Is there something in here that's weird that's going on here, you know? And at first it seems that way. So if you work it out, what's the probability that you get 3 cards in a decreasing row? So it can needn't be a jack, but I would have, again, I'm already going equally surprising, you know, because if it had been king, jack, king, queen, jack, if it had been 5, 4, 3, I'd have probably found it surprising. So, but let's go, what's the probability of getting 3 cards of the same suit in decreasing order? Well, the first card, basically pretty much any card would do as the first of a decreasing thing, so long as it's not a 2 or an ace. So the first card could be any card except a 2 or an ace. So the chance of that first card being the first one of a down sequence is 11 out of 13. Right? So yeah, basically most of the pack would act as that first card. Second card, the 10 here. That now, once we've got the jack, it has to be the 10 that follows it. So there's actually only one card that follows it. So there's only one out of the 51 other cards that could be the next card. So the chance of getting that is 1 out of 51. And for our 9 here, again, there's only one card that will do to make the trend. So there's only a 1 in 50 chance, oops, of yet again of getting that them there. If you multiply this all together, what's the probability of getting exactly 3 in a row? Start, you know, when you start, you just pull cards off the top. It's product of those 11 over 33 odd thousand, approximately 1 in 3,000, which if you remember your stats now, it's jolly sight less than p is 5%. This is less than p is 0.001. Wow, yeah, surely something is happening here. Except, so I mean, I said I've already done some equivalents because I've done it. I haven't just said for the Jack 10 9. I've done for anyone's, but also there was a lot of possible positions. And in fact, I've coloured in here in green, so at the bottom left here are all the possible start positions where you could have a run of 3, and there's 15 of those. And furthermore, I was surprised because it went Jack 10 9. I'd have probably been equally surprised if it had said 9 10 followed by a jack. You know, so probably either order would have done, and any of those 15 positions would have all been equally as surprising or equally surprising. So now we're down to 15 times 2 times 11 over 33,000. It's now more like 1 in 1 in 100, which is still quite surprising. It's still quite surprising. I'd have probably been equally surprised if they'd gone Jack 10-9 in a row going down as well. So that's another twice as many. So now we're down to 1 in 50. What about 3 9s in a row, 3 10s in a row, 3 Jacks in a row? And then remember that I play this day in, day out, hopefully not too much. I do some work in between. I of course only notice when there's an interesting sequence, cherry picking again. So you can see how easy it is to generate these things, and actually when it is a little bit complex, you have to be a bit careful to work out what really is the same or worse. But also to be careful of this. Now, in this this post-hoc hypotheses case, you imagine now, I've done some experiments, I've got some data, and I notice that the expert's response time for this particular thing, the opposite of that's what I'd normally expect, is greater than the novice response time. I think, that's interesting. So I get my data, I split it into the novice and experts, I work out my stats on it, I look at my how to do it, I perhaps chuck it into our SPSS, or I just do it in Excel and work things out. I do my students' t-test because I decided this is normally distributed. I might do some tweaks first. Yay! And it comes out with a 1% significant result, and I think, yes, done it. But what else might I have seen in the data that would have also made me think, ooh, that looks interesting, and do my test? Are there 100 things? Are there 10 things? Now, if there's 100 things that would make me feel equally, ooh, that would be interesting, and I would have done my test, it's a bit like I've done 100 different tests, and all I've done is chosen the one that came out as 1% because it was the one I could see. Because the chances are, if it's going to come out significant, then you're more likely to notice it. If you did 100 tests, you expect one to come out 1% significant. If there were even 10 things that would equally make me think interesting, it might have been to do with the age of the people, it might have been to do with previous domain experience in something else, it might have been to do with the first key they pressed on the keyboards. The more things you've got, the more things that I might have thought, ooh, that looks interesting. Now, it's hard to do this because you see the thing and you don't know what else might have been interesting, but to effectively try and do that mind game with yourself, because you then have to do the correction that says, but actually this is like doing 10 tests. So actually if it's like doing 10 tests and I got 1% significant, that's a bit like getting a 10% significant, which you wouldn't report. You think, that's just 1 in 10 chance of that happening, probably not worth thinking about. So if I really cared about something and say I'd be convinced by the 5%, because everybody says 5%, if there was 10 things I thought were equally good or equally interesting potentially, I should be looking for a 0.5%. If there's 100 that might have been equally interesting, I need to look for 0.05% in each one of them before I would say that's what I've got. So again, this is not there's a bit of this is complicated, but also I think hopefully give you some idea of ways to approach this, because sometimes you have to do this. Sometimes you can't decide beforehand exactly what you're going to see in the data. You see it and you have to look at it, and you can't gather fresh data. There's good reasons to do all that. But if you do have to do this post-hoc hypothesizing, if you have to look at your data and think, aha, I think this was true, perhaps gives you some way to try and give that feeling about whether you really have found something, or whether what you've done is just happen to have noticed a chance correlation, a chance result, and actually there's nothing really there.